Hey guys, so this is a part 2 of a set of videos, and in the part 1 I kind of outlined the problem statement. The idea is to select a few nodes and return all the possible scales that those nodes occur in. Some plugins out there like Scalar2 have this functionality, and I'm sure they're using some really nice sophisticated implementations, but I don't know. I mean, I've got some solution now, and in the part 1 I had kind of outlined what is the way that we can take in order to solve this problem. I do have this implementation over here, like you select these nodes and then explicitly select the scales to check, like I outlined in the first video. But I wanted to come up with an idea where you can just select a bunch of nodes and then automatically it scans through all of the possible scales and returns the correct scales to be used. So a friend of mine, his name is Hosong, and he is a software engineer and a field physicist. He's also my colleague at PayPal. So what Hosong did was he kind of started a new kind of project. It's called autocomplete scales. So he used React to create this where you start entering the nodes like this. And as long as you're sequentially entering the nodes, it will autocomplete, as in it'll result into a set of scales that can work for these nodes. So if there are holes in the nodes, I'll remove this G. So now there's F, B flat, and C. So now this won't work because it's not sequential, but as long as it is sequential, it will continue to give you a result. And he's using a try data structure. I will share the link to this implementation in the description of this video. So he created his own implementation of try right over here. It's a pretty nice implementation. So try requires a children node, which is typically an array in other languages, but Hosong went for this object based property, and that's pretty good because now you can just check against this object because it's object literal and do the rest of the try stuff. So as you can imagine, he has implemented the insert and the starts with method because that's all we need for this particular implementation. So he has this pre-processing step where he goes through all the arrays. He goes through all the scales in Scribbletune and constructs the try or tree, however you want to pronounce it. I think the word tree, it comes from the word retrieval. So tree data structure, and there's some other name for it as well. So what is that other name? There is some other name. Prefix tree, yeah. It's also called a digital tree or a prefix tree. So anyway, so this try data structure or tree data structure, he utilizes this tree data structure to create a massive tree of all the possible scales. And then as soon as you start selecting the nodes, he kind of traverses through that scale. He kind of traverses through that try using depth first search. He's using depth first search over here. And then he kind of assembles the likely candidates for which are the scales for the sequence of letters entered by the user. So if I use the C major scale like this, so it's given a C major. But the only problem with this is great, by the way, I really like it and it can be utilized in some way or the other. But what I really wanted to do was, for example, C, D, E, F, G, A, B, right? This C major now is also, if you go to see, the notes are also applicable for A minor or G Mixolydian or D Dorian. So I wanted those kind of options as well as a result of selecting those notes. And also I wanted something like if I have some holes in the selection, I wanted to return some scales that also took this kind of an input where you have separated nodes like this, but it would still return into something that's specific to these nodes from the massive list of scales that we have in Scribbletune. I do have a rudimentary implementation, and the idea is to apply whatever solution that we come up with to this particular page. I'll improve the UI and whatnot. I wanted to also call out that we have this Discord channel. There's not much people here right now because I have not really focused on getting this out there, but basically we do have a channel here and we keep on discussing some pretty interesting things. I'll post the link to this in the video description. But one of the trusted contributors of Scribbletune, that's Quentin, he came up with this idea of, hey, how about we use bitwise comparisons for doing this? And we kind of went through all of this and discussed some things out. So yeah, so that's the whole idea about this. And let's just go over the code. So obviously this kind of a problem has a pre-processing step, and this pre-detect.js is that pre-processing step. If we focus on this a little bit, what I'm doing over here is I'm going over all the possible scales in ScribbleTune by iterating over the chromatic scale, the C4 chromatic, so that I can get all the notes. And within that loop, I'm doing one more loop where I loop over all the possible scales in ScribbleTune for those notes of the chromatic. And I ignore chromatic, major and minor because they would just be, chromatic would be like applicable for any notes that you provide. Major and minor are kind of covered as Aeolian and Ionian. So this is just a preference at the moment. I might change that, but the point is I don't want to return major as well as Ionian for applicable scales. So that's why I decided I'll just return in case it's these three. Okay, so for all the rest of the scales, I sort those notes of the scale in a very specific kind of custom sort of a way. So what I want to do is I want to sort them out like this. So for example, let me just put a comment over here. Let's say the C major scale looks like this: C, D, E, F, G, A and B, right? That's the C major scale. So what I want to do in my custom sort is, once I pass it through my custom sorter, I want it to come out as A, B, C, D, E, F and G. That's what I want to convert the C, D, E, F, G, A, B to this, and that's this custom sort. I'm using some rudimentary method to do that by assigning some numbers to each of these notes. So please note that this is like we are deviating completely from the musical context here. We just want to kind of return a sorted set of notes so that let's say we have the A minor scale, which is A, B, C, D, E, F, G. That's the A minor scale. So once you move this through the sort method, that will also return into this A, B, C, D, E, F, G, obviously, right? And then to take that example further, let's take D Dorian. D Dorian is D, E, F, G, A, B and C. That's D Dorian. So once I pass this D Dorian through my custom sort, that also would return into this A, B, C, D, E, F, G. I wonder you see where I'm going with this. The idea is I want to be able to go through all of the scales and identify each of them by their notes. So for example, if somebody inputs something from D in this particular order, I still want to return a set of scales that are applicable even if the order was different, which is why I'm kind of converting all of these scale notes to a particular order, which is like this. The other thing I wanted to do was the next step is of this solution is to then create a bit representation of that A, B, C, D, E, F, G on the 12 notes. So for example, this is A flat A, B flat B and so on. So imagine for A, B, let's say this was our scale, right? So what I want to do is I'm going to iterate over this A, B, C, D, E, F, G, and then at the same time I'll maintain a pointer across this chroma scale that I have got, or this chroma array that I have got. So these two pointers which initialize at 0, and what I'm doing in this method called getBits is I'm walking over this entire array in a while loop and matching the incoming notes. So for example, A does not match with this, so I'll set a 0. I'll put a comment. So 0 for A flat, then I jump over here, that A is equal to this A, so I set a 1. Then B flat, there's no B flat here, so 0. Then B, there is a B over here, so 1. C, again 1. D flat doesn't exist, so 0. D exists, E flat doesn't exist, E exists, F exists, G flat doesn't exist, G exists. So once I iterate over the array for each of these items, I will be coming up with a binary representation of each scale against the chromatic, which means even if my input was A and B, or my input was A, B, let's take maybe E Phrygian, E, F, G, A, B, C, D. So both of these have the same notes, this E Phrygian and this C major. Once I send them through my custom sort, both of them will become A, B, C, D, E, F, G. And then if I move them to this get bits function, it is going to return this string. Now what I can do is I can hold a dictionary object which kind of checks if it has an entry for this item. If it does, then it just simply pushes the scale into that item. It's an array. In another language, it could be a linked list or something of that sort. So if this item exists, then I will push the array in question into that array, or I'll just create a new array with this entry. So let's get rid of this and run some code. So these are the three utility methods that I put inside a file called utils.js, and within that pre-detect, I'm pulling that utils over here like this. I'm also pulling in ScribbleTune so that I can walk over each of these. So let's just quickly, I think I'm running detect. So let's run nodemon. So to start with, let's just console out the name of the scale that we are kind of iterating over. And that's going to look like this. And now if I do node pre-detect, you can see that all the names of the scales that are possible in ScribbleTune are printed out through this. One thing I learned while doing all of this is I was initially using nodemon, and let's do that. Nodemon pre-detect.js. If you run that, it starts going into this endless loop. And that is because nodemon is watching these files, all of these files. And in here, I'm using fs.write file, which is writing to a JSON file. So every time it changes, it kind of loops over. So to kind of circumvent that, if you're writing a JSON file within a JS script and you're using nodemon, I think you can do something like nodemon name of the file and then ext like extension, and you can set it to JS so that it runs only once. See, now it's not looping endlessly because now it's only watching JS files with that ext extension. Anyway, so I'll come to that, but the point is I'm kind of walking over all of these scales one by one. Then I'm sorting them with my custom sorter algorithm where it will convert something like C, D, E, F, G, A, B to A, B, C, D, E, F, G. So that's what I'm doing through that custom sort. And in that custom sort, once that custom sort is done, I'm also passing the updated order of nodes to this method called getBits, which, like I mentioned earlier, is just walking over this chroma array and building a string which looks like 0, 1, 1, 0 and whatnot. So let's print that out as well, this bit string. So maybe we can remove this, or how about we take this and put it over here so that you can see the name of the scale and its representation. So look at this. For example, B Locrian, this scale has this bit representation. Then something like B flat 4 bebop has this this binary representation. So basically each of these scales, all of the scales, possible scales in ScribbleTune now have a bit representation. I hope that makes sense. And within the code, what I'm doing is, if I see that the bit representation that I've calculated for the nodes is already in the dict object, the dictionary object, I'm just pushing the scale in here. Else, I'm creating a new array with that scale. That's all I'm doing. And at the end of this file, I'm using fs.write file to create a JSON file out of all of that. So I stringify the dict or the dictionary object, and I create a JSON file out of that, which means I run this whole thing only once and then store a JSON file, which looks like this. So this JSON file has bit representation of all the scales and an array to accommodate the names of the scales. So I think I can get rid of this, this digit over here. The octave is really not required. And maybe I should do that right away. So when I'm pushing stuff over here, what I can do is, I don't know, I don't like doing it like this, but I just wanted to get rid of that digit, if you know what I mean. And now if I run this, it's already running. So if I go back over here, as you can see, all the notes, all the digits are gone, all the octaves are gone, and now it makes more sense. So So yeah, so this pre-detect script walks over all the possible arrays in Scribbletune. I'm sorry, all the possible scales in Scribbletune for each and every note of the chromatic scale, and generates a JSON file which has a mapping for each representation for a set of scales like this. So if you had some scales which had some common notes, they would all assemble like this in each array. I know it sounds damn confusing, but it's really all this thing is doing is just setting aside all the common scale notes like this together in a JSON file. That's what it is doing. So as you might know, Ionian, Dorian, Phrygian, Lydian, and these modes, they all have the same notes, right? And they are C, D, E, F, G, A, B. That's the notes. And then this is something else. All these scales like C major pentatonic and D Egyptian or A minor pentatonic, they have the same notes. So that's why they're all clubbed together now. So the next step is in the detect phase is to do a bitwise AND operation on the input. So the input is going to be something like this. So for example, here I have set aside a set of notes which seem to have the C Lydian scales notes over here. So C, G flat or F sharp, G, A and B. So when I run this, I don't need this because I was just trying something out. Basically there are 500 items in this scale groups. So the iteration that takes place during detect is going to iterate over the scale groups, which is made up of 500 items every time you want to detect something. So that is the drawback of this thing, and in a subsequent part we'll try to explore graphs for this, but for now this is the most efficient thing that I have. And if you have some ideas, please do let me know in the comments or whatever. I'm more than happy to solve this in a better way. Anyway, so at the moment we have this JSON file. It has 500 plus entries like these, and we are going to iterate over those 500 entries to determine if a set of notes, if the provided set of notes exists in any of the scales, and if they do exist, then return those scales. So let's just run this for this particular console. So this was pre-detect. Let's go back to maybe just detect. Yeah, so as you can see, this C, G flat, G, A, B, that was the input. It has returned these scales for these notes. So if you had a melody which had these 5 notes and you thought that, oh okay, this is in the E minor scale, and you were playing something in the E minor scale and you came up with these notes. So yeah, obviously we have the representation right here for E minor, that's E Aeolian. But let's say you wanted to kind of take it further and add a flavor to it. So you could just take some other scale from here. For example, you could take something like E minor hexatonic, or you could take something like G major augmented. And since these 3 notes for which you ran this detect function are available in these notes, this G major augmented will come with its own set of notes, and it will add that flavor or whatever the lead or harmony that you want to put on top of your melody. I hope that makes sense. So if I kind of remove or make it something like A flat, let's see what happens. So let's say I had this melody with these specific notes, then I know that now I have an option of these scales to consider for playing a lead over it or coming up with some harmony parts or whatever. So yeah, I think that's about it. And before I go, I just wanted to kind of show you what is actually going on in that bitwise comparison. So for example, if you had something like 101, okay, and you did a bitwise AND with 111, what it does is, it, as you might know, that the AND operator is just going to see for every 1 that it encounters, it is going to set that 1. So only if both of the bits are 1, it is going to set a 1. If they are not, it's just going to set it to 0. So which means if I do 101 and 111, only the first and the third one are going to get in the result. They're just going to appear in the result, the first one and the third one, and the center 0 thingy, the second one over here, since it did not match, it's just returning a 0. So let's take another example. Let's do 1010 and 0101. Okay, so it's returning 64. Screw the response that it has given. Basically it is not 1010. So the way this whole detect thing is working is, I will do something like 1010 and 1010, 111, and check it against 101, which it is true. So for every input, so the notes that we are getting over here, like the C, G, A flat, B, whatever, I'm first sending it to the get bits method, and get bits method returns something that looks on the lines of like this. It looks like 101, something like this. So it's like 12 character string, or 12 bits if you will, 1 bit for each note of the chromatic scale. So it generates this, right? So if 101 was, so I'm like simplifying, oversimplifying it. Let's say it was a 3-digit binary representation. So if 101 is the input and I wanted to check if it exists in this 111, so it, by all means it does. 101 does exist in 111, in the sense there is a 1 over here and there's a 1 over here. So if I do a AND on it, it is going to return the original value again, which is 101. And if it is true, then I'm considering that this particular scale is good for this set of notes. I hope that made sense. So every time we run a detect function, what we do is we just go over all the items of the scale groups, which I'm calling it over here like this. So each of these bit representations, we go over all of them, we walk over 500 of them and compare it with the incoming, the inputs bit representation. If that bit representation is within the iterated scale group, then I'm adding the scale group's entries into an array that I ultimately return. So for example, if I do detect so and so, it is returning this array. I will share all the lists. I'm going to put this project somewhere online, like the way Hosong has put it over here. So something like this, I'll put it over here and then share that link. And later on, I'll also build an app that kind of utilizes this functionality. I'll make a video for that as well. Okay, that's it for now. Thanks for watching. Bye bye.